Hello all. Our project this semester for CS6620 is Implied Role Assignment for Kubernetes. My name is Niharika and my partners are Anand, Rahul, Roy and Newton. Our mentor is Adam Young working at Red Hat. In this presentation, we will talk about the tech stack we got to work on, our problem statement, project description, overview of our goals, the architecture, some key decisions we took for design. We will walk you through a demo and display the results of our project. Here are some of the key technologies that my teammates and I got to encounter during this project. Many of you might already know Kubernetes, also known as K8s, is an open source system for automating deployment, scaling, and management of containerized applications. It groups containers that make up an application into logical units for easy management and discovery. Some of Kubernetes features being automated rollouts and rollbacks, service discovery and load balancing, storage orchestration, secret and configuration management, automatic bin packing, batch execution, IPv4 IPv6 dual stack, horizontal scaling, self-healing, and being designed for extensibility. One of the prerequisites before starting this project was the ability to spin up a cluster, to deploy YAMLs on the file, to deploy images, to run some containerized applications on Minikube. Role-based access control. RBAC restricts network access based on a person's role within an organization and has become one of the main methods for advanced access control. The roles in RBAC refers to levels of access that employee has to the network. Employees are only allowed to access the information necessary to effectively perform their duties. Access can be based on several factors such as authority, responsibility, and job competency. In addition, access to computer resources can be limited to specific tasks such as ability to view, create, or modify a file. As a result, lower-level employees usually do not have access to sensitive data if they do not need it to fulfill their responsibilities. This is especially helpful if you have many employees and use third parties and contractors that make it difficult to closely monitor network access. Using RBAC will help in securing your company's sensitive data and important applications. Especially in Kubernetes, RBAC API declares 4 kinds of Kubernetes objects: role, cluster role, role binding, and cluster role binding. We can describe these objects, amend them, use tools such as kubectl, just like any other Kubernetes objects, which will further be discussed in the upcoming slides. Programming in Go. Essentially, prior to starting this project, we had to learn the basic programming in Go. And as a result of this project, we have written our operator that is based in Golang. Kubernetes is attempting to solve the problem of scale. The RBAC model needs to support improved delegation in order to scale. As I walk you through our problem description, I have highlighted a few key points on the slide for you to go through. Kubernetes roles maps to a set of permissions to perform operations on resources. Today, there are relatively few roles defined, with each being mapped to a large number of APIs. This is a very coarse-grained access control. If deployers are going to provide a finer-grained model, the number of roles will quickly escalate. To minimize the burden on administrators, it must be possible to grant a user all the privileges they need for a specific namespace with a single role assignment. This is not possible with the current assignment mechanism. As an organization increases in size, the amount of hierarchy must increase accordingly, or managers quickly become overwhelmed with the sheer number of requests by subordinates. A manager has responsibility for all the operations performed by a subordinate. Even if they never choose to perform those operations directly, the authority to perform those operations comes from the superior to the subordinate. If a superior cannot delegate appropriately, an organization cannot function. When interacting with automated systems, a user should be able to delegate a subset of their capabilities. If a user is a system administrator, they are irresponsibly delegating full administration to a user when the required operation is not a privileged operation, or even if it affects only a subset of resources. Even casual users should be able to provide access to a subset of their resources without providing full access to all of them. In order to split apart permissions this way, the roles need to provide sufficient information to deduce that the larger and more powerful roles imply a smaller and more limited role. This is also not possible with the current role assignment mechanism. In this project, we write a Golang based operator that will handle the RBAC assignment mechanism that was lacking before. If you can look at the role hierarchy on this slide, currently what is provided in Kubernetes is that if user 1 is assigned admin, that's all the privilege he will have. A user 2 author, a user 3 reader. But after deploying our operator, a user 1 will have admin, author, editor, reader. User 2 will have author and reader, and user 3 will have reader.
Thanks, Nirika. Now, me and Rahul will talk about the design of the architecture of our project. Before that, I need to go over some related concept of role binding. So in Kubernetes, role-based access control API declares 4 kinds of Kubernetes objects, which are role, cluster role, role binding, and cluster role binding. So role and cluster role basically contains the rules that represent a set of permissions. The role set permissions within the particular namespace, and the cluster role defines the permissions on cluster scoped resources or on namespace resources and be granted within an individual namespace or be granted across all namespaces. So in one word, if you want to define a role within a namespace, you use a role. If you want to define a role cluster-wide, you use a cluster role. So the role binding grants the permissions defined in a role to a user or to a set of users within a specific namespace. And also the cluster role binding grants that access cluster-wide. So this is the basic idea of role binding. And now I want to talk about the initial cluster setup of our project, which including creating the role inference custom resource definition. Then we use this CRD to create the role inference custom resource. We also created all the roles and assigned these roles to the users by creating role bindings. And now Rahul will talk about the next part of the design of the controller we use in our project.
Whenever a role binding or inference role custom resource is created, we get the user and get all the implied roles for the assigned role. We then check the user's current assigned role and reconcile them with role he should have based on the current role assignments. We create or delete role bindings to achieve this. Once we reach our desired state after reconciliation, the user will have all the roles assigned to him. This would keep happening whenever any change event is triggered. Now we'll hand it over to Roy.
Okay, there are several key decisions we made to implement our above design of this project. So in Kubernetes, an operator is a custom Kubernetes controller that uses custom resources to manage applications. So it will watch a custom resource type and take actions to make the current state match the desired state in that resource. So the operator introduced new object types through the custom resource definitions, and the CRD can be handled by Kubernetes API, and in conclusion, in role-based access control policies. That is what we need in our project. So in our controller, we approach related functions to create, to read, and to delete our role bindings. We also use BFS algorithm to parse our whole role implications graph in the controller. So these are the key decisions we used in our implementation of our project. And now I will welcome Anand to provide a very detailed demo for how our project runs.
So now we'll be demoing the implied roles operator. In this demo, we'll run the controller. We'll set up role bindings with YAMLs. We'll set up implication rules with YAMLs. Then we'll just check the resources that are created. Then we'll delete role bindings and check that. And after that, we'll create the role binding again, delete the implication rule, and then check to see what happens. So we'll first start off by running the controller. So this is how we run the controller. So you can see it builds and it starts running. So controller is now running. I'm just going to clear the screen. So I'll show you the resource that we have here that we're going to create. So if I just show you what's here, so you can see that we have one role binding. It's called role binding developer, and we have 3 roles. The roles are developer, guest, and writer. I can show you what, for example, a developer role looks like. So if I just do that, so you can see that the kind is role, the name of this resource is developer, and these are the permissions that it has, for example. I can also show you what the role binding looks like. So let's do that. You can see that the kind of this resource is role binding. The name of this role binding is developer role binding. It has 2 subjects, so a noob user, right, and a pro user. And then it also has a role that it references, so that's the developer role that we saw earlier. So now that we have this in place, let's just apply the roles. So actually we can start, I can actually show you that there are no roles in this cluster, and there are no role bindings in this cluster, and there are no implication rules in this cluster, so the cluster is completely clean. So now what we'll do is we'll apply the roles. So for that we do that. And then we see that now there are 3 roles that are created, and you can see that we have 3 roles that are created in the cluster. So next what we'll do is we'll create role binding. So the way this works is that our controller or our operator actually watches for changes in role bindings as well as role implication rules. So now when we create the role binding, we should see some changes in the controller. That is, the controller should have run once. So now what we'll do is we'll apply it again. So now you see that the role binding resource has been created. So if you get role bindings, you see that we now have a developer role binding that we saw earlier, and then it also references a role called developer here. And you see that the controller is actually run one time. So let's clear the controller again. So now what we're going to do is we're going to basically apply a role implication and then see what changes in role bindings we get. So to do that, we're just going to go out and go there. So here we see that we have 2 implication rules. So for example, the developer implies writer rule and the writer implies guest rule. So I can show you what that looks like. For example, this rule, see that the name is developer writer rule. The kind is role implication rule. So this is a custom resource that we have defined. And also the implication rule is that the parent role is developer and the child role is writer. So what that means is that if somebody has the role of developer, when we apply this rule, they should also get the role of writer. So now we can apply this role implication rule. So this should cause our control to trigger again, and then it should also create a new role binding that gives anybody with the developer role the writer role. So now what we'll do is we'll apply this again, right? So we'll apply the first one here, and we see that it gets created. So we can now see that this resource has been created in the cluster, and we see it here. We also see that our control has run here in the top tab. And now what we should see when you get role bindings is that an additional role binding should have been created. And what we see here is actually that we see here that a new role binding has been created. So originally we just had developer role binding here, and now we have role binding. 2 role bindings have been created, one for each of the subjects for the developer role. So for example, the developer role binding had actually the role developer being assigned to a noob user and a pro user, and now we have one for each of them, and each of them have gotten the role writer. So now we'll see the next role binding that we have, which is implication writer guest. So implication writer guest is the same as before. The only difference is that the parent role here is writer and child role is guest. So now when we apply this, we should ideally have, since these users pro and noob originally had the developer role, they got the writer role. And now since they have the developer role, and so now that they have the developer role, the developer role actually implies the writer role, and the writer role actually implies the guest role. So now they should get guest role as well. So now when we apply this, we'll see that that is going to happen. We'll see that the controller runs again. So you can see on the top that the controller runs again here. And then when we get role bindings, we see that we now have a role binding that says noob developer writer, noob developer guest, and pro developer guest as well. So they've gotten both the guest roles for both users. So next what we'll do is we'll actually delete a role binding to show that these roles will now disappear. So since the users pro and noob have been assigned to developer, if they are no longer assigned to developer, that is we delete the role bindings, they should actually lose all of the roles that are implied. So let's do that. So what we'll do is we'll just delete the role binding here. And since the role binding is deleted, so now we see that our control actually runs again since this happened. And now if you get role bindings, we'll see that while we still have the implication rules, the role bindings have now been deleted. So if you do that, we see that there are no role bindings at all. So for example, earlier we had these role bindings that were implied role bindings, and now we don't have them because the developer role binding got removed. So now, so what we can do is we'll now reapply the developer role binding and see that they come back. So now the developer role binding was created again. So you see that it's been deleted. The controller has run again. So let's clear the controller for now. And then when I get role bindings here, you can see that it's reached the previous state, which is that it got all the roles again, which is the same. So you can see that it actually got these roles again, which is the same as what it had earlier, right? So now what we'll do is to test something, we are now going to delete an implication rule. So what we do here is we delete one of these two. So for example, I can choose to delete the writer guest implication. So when I delete the writer guest implication, that means that like the users that got the guest role because they had the writer role, they should now lose the guest role, right? So now what I can do is I can actually delete that, right? And you see our controller ran again, and it deleted the custom resource. And then now if I get the role bindings, you see that the guest roles that we had here earlier are now missing from this. So I can also show that how we find out what role bindings come from implied roles. So for example, we have this role binding here, for example, pro developer writer, which actually comes from the implied role. So if we actually get this role and output it, we see that this role binding is actually going to be tagged with a label that says the type is implied, and we filter by this, and this is how we get all role bindings that we have created as part of the operator. So that's it for the demo.
Thanks, Anand. And here are the conclusions of our project. We were able to accomplish most of our designs according to our design documentation. As Anand showed in the demo, we were able to create role bindings and implication rules. And when we create or update implication rules, our role bindings will be automatically updated as well. We were also able to delete our original role binding, along with automatic deletion of implication rules applied to that role binding. And when we add that role binding back, the implication rules we first added on that role binding will come back as well. On the opposite, when we delete implication rules, the original role binding will not be affected, and only the implication role binding will be deleted. Here are the things we didn't accomplish due to lack of time. We wanted to write more efficient code, but we didn't have time to optimize our current code. We also wanted to set up testings for our operator, but ended up didn't have enough time to do so. And this is our final demo. Thank you.